Hello, this is for those who would like to use my worksheets of complex integration. There are three kinds of templates. The first one is CircleGGB, integrates along a circle. The second one is AutoGGB, integrates along segment and arcs excluding circles. The third one is manual GGB, integrates along any parameterized curves up to 10 sections. I'll show you example. Okay, let's start with CircleGGB. This is Fz. Now it's 1 over z. This is radius. Now it's 1. This is the number of division. It's 3 now. And this is z1, z2, z3, and this is fz1. It's 1 now. This is fz2, and this is fz3. And we can increase the number of divisions. Okay, if you want to increase more, you can change it from this property. Okay, let's integrate. Now it's 1 over z, and the singular point O is inside the curve, so the value should be twice by I. Okay, but if we move the circle, and if it doesn't contain origin inside, the value should be 0. We talked about this before. So that's it. It's very easy to use CircleGGB, and it is very stable. But you can't delete P. But I'd like to talk about 2 other functions. Otherwise, it's not very interesting. So they are very interesting functions. One is z-bar. Reflection against the x-axis. It's called complement, but there is no such function complement in GeoGebra, so we have to make it. And I made z-bar using this property, z-bar equal absolute value of z squared over z. Let's see if it works well. First, we change the property to complex number. Absolute value of a squared over a. Okay, looks like it works. So we can define z-bar with this definition. Sorry. Initialize. It's interesting. See? Fz or Fz touches x-axis. And the value is twice by I. It doesn't change. But if you change the R, from 1 to 2, it increases. The integral is 25i, which is about 8 pi I, okay? About 8 pi I. So before, when R was 1, it was twice pi I. So it's 4 times bigger than when it was R was 1. So actually, z-bar, function z-bar is not regular function in the complex plane. So you can't differentiate on every point on the complex plane. So it behaves very differently from regular functions. This is a property of z bar. So if you integrate z bar along any curve C, it is equivalent to the area of inside C by I. So in this case, pi r squared by I. So this is the properties of z bar. So it has very different properties. Okay. So next we are going to move to log. As we talked before, 1 over z dz can't be defined because you can circle twice along the origin. But if you cut the plane, from here to somewhere, and if you don't cross this cut line, so the value is uniquely defined. And when the cut line is, normally when the cut line is negative x-axis, it's called principal value, and it's written log z. Sometimes it starts from the capital L. So we are going to integrate this function log z. Okay. So what will happen? It doesn't cross the cut line, so the integral is 0. As long as it doesn't touch the cut line, the value is 0 because it's a regular function if you don't cross the cut line. But once you cross the cut line, the value changes. And it keeps changing. See, it keeps changing. Interesting. So this is circle GZB and two interesting functions, z bar and log z. So second, odds GZB. This is the worksheet I used for all of my presentations. So you can integrate along many segments and many arcs. So 3 kind of works. You can't use circles here. So if you want to integrate along a circle, you have to use 2 semicircles. Why this kind of program, you may ask? Because program was not easy. Because with GeoGebra, you can't put different kind of object in a list. So if you have 2, there are 3 kinds of object here, points and segment and arcs, and if you have one more, it's very complicated. So I didn't want to do that, and you don't need circles because you can have 2 semicircles. Anyway, let's see how it works. You need only end point and starting point and the name of a path. You don't need the name of this middle point. a point, segment or arc, and point. C to big C to through D to E. Okay, let's initiate, and then you can integrate. Okay, it's easy. But one thing is very important. You can't use prime or dash for the point. Like if you use E prime instead of E, it will crash. Okay. Now it crashes. And once it crashes, it takes time to recover from it, unfortunately. See, line 31, 27, there are so many lines. Okay. But normally you can recover. See? So why there are so many errors? Because I wrote all the programs with scripting. There are many scripting. So now the last line is 52. The reason why I wrote so many scripts here, because when you integrate, so you sometimes feel like once one integration is over, you'd like to delete a point. And if you delete a point, so everything disappears. If the object is linked to an object, so you have to create object like vectors and so dividing point you have to create from the scratch, which means you have to shut down this file and open the file again. So I didn't like it, so I wrote all the programs under this button so that I can recreate the conditions. Okay, that's it. This is auto GGB. Don't use prime. The third one, manual GGB. You can integrate any parameterized curves up to 10 sections. I didn't use this worksheet at all in the presentations because you don't need it normally. 99.9% of exercises in textbooks can be done with AutoGGB or CircleGGB. This is just for fun. So this is a cycloid. This is a parabola. So let's it's already initialized. So let's integrate. Okay, it is of course 0. So you can add some more sections. You increase the number of sections, 3. And you can change the size from properties. And normally you use sequence to make points. So what kind of parameterized curve? It's sine curve from 0 to ni pi. See? So it goes from here and return to O and then goes to twice pi. Okay, let's integrate. So you can increase the number of sections up to 10. See, up to 10. And you can't decrease less than 1, of course. The one thing is very important. You can't use small s for sequence. It will crash. Unknown command sequence. So GeoGebra doesn't recognize small s sequence. So you have to use capital S for sequence. It's a little bit strange because you can use small s for sine t or small s for cosine t, but you can't use small s for sequence. I don't know why. But anyway, so it's I can't change it. So important thing is please use capital S. Okay? So this is manual GZB. So that's it. You can download worksheets or PDF from the link below. These worksheets are very different from normal worksheet. I think you noticed already. I forced GeoGebra to work to its limit. Thus, unfortunately, it crashes quite often for complicated integrals. If you are lucky, Ctrl-Z may work for Windows, but if it doesn't work, you have to close the file and reopen it. And normally it works, but unfortunately, it is possible that you have to restart your PC, but it's very, very, very rare. Anyway, it is recommended that you save important files before playing with this worksheet, and I have no responsibility whatsoever if you lose your important files. Sorry. Thanks for watching. I hope we can see again. Bye bye.